All right, that kind of finishes the pre-processing and we're ready to rock and roll. So we're gonna define some variables. Batch size 128, look back is 720. So this is the equivalent of 5 days. Delay is equivalent of 24 hours. Yeah, and step 6 means 1 sample per hour. All right, so let's run this. Done. And now what we need to do is, so let me put some text in here. Now we will define our generator. All right, here we go. Actually, what I'm gonna do is I'm gonna write a little bit more text here. Here we go. Yeah, so we're gonna build a generator that actually will yield batches, number of samples, and the target. Yeah. So here the rest is pretty straightforward. So here, yeah, this I explained in the previous session that we can actually shuffle, meaning we don't need to take the indices in order as long as we stick to an index minus loopback plus delay. It doesn't matter where we sample the index. All right, now the generator is quite a complex block of code. We will go through it. If you don't understand it entirely, I would just not worry about it. I would just continue. It's probably something we can reuse later on, but it's quite complex. All right, so we define a generator here. So we have as arguments the data, the loopback, delay, minimum index, maximum index, shuffle is false, batch size is 128, and step is 6. So this data here refers to the whole data frame. Remember, we called this float data. Here, this is the data, okay? Now what we're gonna do is, if there's no maximum index, that basically means that the index, the max index is the length of the data, and we know it's 425.51 minus delay, so minus 144 minus 1. Yeah, minus 1 comes from the fact that we start our index at 0. So this is going to be important for the test set. Let me show the generator for the test set. So this is our test generator. So we take float data. Here nothing changes, but you see the index start from 300,001 and the max index is none. So in this case, your maximum index will be as defined here. Yeah. Your index in general will be your minimum index plus loop back. So that's actually the observation point of I equals 720. But basically it's going to be 790. Yeah, if you start from 0. Okay. All right, and then we're gonna go through a loop. You see here while true, that means that the generator we know does not stop. So we have to tell it when to stop. And so here you have if shuffle, meaning if you shuffle the data, and we know that we only want to shuffle with the training data. So let me paste the generator for the training data. So here you start at 0 and go to 200,000, and here you see shuffle is true. So I know that this if is valid for the train generator. So basically rows is going to be a list of integer numbers randomly chosen anywhere between minimum index plus loopback to the maximum index. Yeah, and the size is the batch size. Yeah, you just define a set of numbers randomly in the range between minimum index plus loopback. That would be, in the case of training, would be from I equal to 719 to max index, and in our case, max index is 200,000. All right, let's continue. We here with the else. All right, so the else reflects on the validation and test set, but I have not copied the validation generator in, so let me do that first. All right, here we are. So let's go back here. So the first thing that I'm gonna check in my else statement is if I plus the batch size is gonna be larger than the max index. So the max index for validation is 300,000 and for testing is 420,406. If it would be the case, then I would keep I as the minimum index plus loopback, yeah, because I don't want to go above max index. If I plus the batch size is smaller than max index, then I'm on this row. And then basically what I'm going to do is I'm going to create a list with a bracket or a range from I to I plus the batch size or the max index, whatever is smaller. All right. So that's just going to create evenly spaced values between 200,001 and 300,000 in the case of validation, or 300,001 and 420, 406. Yeah, 420, 406, correct. And then what we're gonna do, we're just gonna increment I with the length of rows. Yeah, just to be clear here, length rows. So if we look at it, that will go from I to I plus the batch size. Yeah, so we're gonna basically add the batch size to have our next I. And of course, this is in case that I plus the batch size is smaller than max index. So the next thing we will do is to set the dimensions of our tuple samples targets. And for samples, the dimension of the tensor will be, so we're gonna take length rows, and this will be the batch. Then we have look back divided by step, and that will be your samples. And this last piece here, float data dot shape -1, basically means the columns of this float data. And these are exactly the 14 features. In terms of targets, the same thing. The targets will also have a length as the batch size and will contain one prediction for each sample in the batch. All right, so now we will build our samples. So we're gonna iterate through rows. And first, in terms of indices, we're gonna take a range, yeah? So row j minus loopback will be the start of one observation, and row j will be the end of the observation. And we'll do that in steps. Yeah, these are steps by 6, as we only sample one time per hour. The samples j, we then relate to the data of these indices. So basically, you're gonna create a tensor with the batch size, the steps, and the features for that sample. On targets, what you take there is the data of row J plus the delay. And that is your target temperature. And the one here between brackets actually points to the temperature column. Yeah, because in the data, index 1 means the second column. And if we go back on top here, so this is the first column, yeah, and this is your second column. So the second column, maybe I can see it better a bit higher. So if we take date time out, P is the first column and T is the second column. So by pointing data to this one, we actually single out the temperature, yeah, which is basically the target. And then at the end, we're going to yield samples and targets. Now we know that a generator does not stop if you don't tell it to stop, so we will need to deal with that as well. All right, so let's do this. So basically, we're gonna assign the number of steps, and that's basically between 300,000 and 200,001 minus look back. You're gonna divide it by a batch size of 128, and that will actually give you the number of steps that you need to take. And the same we do from the test set, and we do exactly the same. And so we avoid that the loop goes on forever. But why shouldn't there be a training steps? And actually we're gonna add one, because there's no reason that there shouldn't be any. So this we will call train steps. Yeah, train steps. And that goes from 200,000 minus loop back, yeah, and also divide by 128. Yeah. So let's run the code to see where we are. So run before. So that should work. Here we go. Done.